Okay, so today we're going to be finding concavity of the given function. Part A says to find the EVPs, or the extreme value points, and Part B says to find the PIs. So the given function is negative 5x to the third plus 4x squared plus 16. For Part A, for finding the EVPs, we need to take the derivative of the original function. So f prime of x is going to be equal to negative 15 x squared plus 8x. The next thing we have to do is set this derivative equal to 0. So we have 15x squared plus 8x equal to 0. And the only common factor between these two terms is an x. So we're going to factor out an x and get negative 15x plus 8. So now that we have one value for our x, we need to find the other. So we have to set 15x plus 8 equal to 0. Subtract an 8. Now we have negative 15x is equal to negative 8. Divide by negative 15. And x is equal to 8 over 15. Okay, so now we've made a derivative sign chart so we can find our values for these two x's. It's going to look something like this, so I went ahead and did it on my own. To find your values for 0 and 8/15, you're going to plug 0 and 8/15 back into your derivative, and then for 0, you're going to come up with a 0, and for 8/15, you're also going to come up with a 0. Okay, the first thing we're going to do is we have x is less than 0, so we need to pick a value that's less than 0 to plug back into our derivative. So I'm going to go with negative 1 just because it's an easy number. So as you can see on the calculator here, I've went ahead and plugged that in. So the value we're going to come up with is a negative. So we need to mark that it's a negative number. The next thing we have to do is find a value that is in between 0 and 8/15. So 8/15 is just a little bit more than 1/2, so I'm going to go in with 1/2. So I plugged it into the calculator. I plugged in 8/16, which is also 1/2. I came out with a positive value. So I'm going to mark a positive. So as I just said, 8/15 is a little bit more than half. So for the number I chose greater than 8/15 to plug into the derivative was 1. And so I went ahead and plugged that in, and I came up with a negative value. So I'm going to mark a negative here. Okay, so now we need to look at the values, or the positive and negatives that we've gotten from plugging in the values. So here we have a negative, which the slope is going to be a negative line. And we have a positive, and it's going to be positive, and negative, so the line's going to look negative again. Here, we obviously have a minimum, and here, since the lines are going up, we're going to have a maximum. So the next thing we need to do is find the EVP values of 0 and 8/15. Okay, so EVP stands for extreme value points, so we obviously have our x values, but now we need our y values for our minimum and maximum points. So what you're going to do is, for your minimum, you're going to take your x value of 0 and plug it into the original function, and then I've already done that on my calculator. So as you can see, I plugged in 0 and I got 16, so the y value of my minimum point is 16. The last thing we're going to do to find our EVP values is look at the maximum, and we're going to plug in 8/15 into the original function up here to get our y value. And it's going to come out with a decimal, but as a fraction, it's going to be a really ugly number. So it's 11,056 over 675 as your y value. And there you have your EVPs. So part B says that we need to find the points of inflection. So what we need to start out doing is taking the second derivative. So we're going to take the derivative of the first derivative. So we have f double prime of x is equal to negative 30x plus 8. So we need to factor something out of this equation, and the only thing that these two terms have in common is a 2. So we're going to factor out a 2, and then we're left with negative 15x plus 4. The next thing we're going to do is set these two things to 0. So 2 is equal to 0. That doesn't work. And then so that x value is gone. And now we're going to be working on this part equals 0. So negative 15x plus 4 is equal to 0. Subtract 4. Now you have negative 15x is equal to negative 4. divided by negative 15. X is equal to 4 over 15. Okay, so now we're doing a derivative sign chart since we have one value for x. So when you plug 4/15 into your second derivative, then you're going to come out with a 0. Now we're going to plug in a value that's less than 4/15. So again, I chose -1 because it's an easy number. On the calculator, I've plugged it in and I've come out with a positive result. So I'm going to mark that on my derivative sign chart. The last thing we're going to do on this derivative sign chart is plug a number that's greater than 4/15 into the second derivative. So I chose 1 and I did it on the calculator and I got a negative value. So it's negative. Now we're going to draw our lines. So this has positive and this is negative, and this is a point of inflection because it comes like that. Since this one's going up, it's a concave up, which is CC up, and this is a concave down, which is CC down. The last thing we have to do is find the coordinates for the point of inflection. So to find our y value, we're going to plug 4/15 into the very original function up here. I went ahead and did it on my calculator, and I came out with another ugly number, which is 10,928 over 675. Now you have completed both A and B, and you have found your EVPs and your PIs, and that's how you find concavity of a function.